Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Eduardo. Hi, Eduardo.
Hey,
Welcome for the third time, right? So
yes, this
tell
is
us a few, tell us a few words about yourself and about the tool you want to show us this time.
yeah, sure. So thanks, Alexei, for having me for the third time. I'm always excited to show what we are working on to the data talks community. So today I'm gonna be, well, maybe first some background on me for people that don't know me. So I'm the co-founder of Plumber. We are a startup that develops open source libraries for data scientists, machine learning engineers. We have Plumber, we have a bunch of others, and today I'm showing JupySQL, which is the project that we've been working the most in the last few months. It has lots of users, lots of excitement, and recently, actually last week, we released a big update. So the presentation is going to cover the new things that we added. So I'm pretty excited to show all the new stuff.
So what is this tool about? So I think it's SQL for Jupyter, isn't it?
Yeah, exactly. So kind of the backstory is that there's a project called IPython SQL. So we forked it from that project and we started adding more features because we felt like there was a need in the community to have new features for SQL. And actually recently, the original author of IPython SQL agreed to pass over the project to us. And we are still working on the details, like how we are gonna coexist maybe for some time. So we still have to talk to her, but it's great because we met her at PyCon and she was really excited. So we are both excited that we're having this next step for the library because it started as, well, let's add a few things. Let's fix a few issues because some of the customers that we have and some of the members of our community were having some challenges with SQL, and it started as a kind of a side thing that we were doing, and now it's growing, and it's been great to be working on this.
Yeah, I want to see the demo.
All right, let's do it. So I'll be going through the documentation and also run this. So this documentation is interactive. So the first thing that I want to say is if you go to jupysql.plumber.io, that's the documentation page, and you'll see this little rocket icon here. So you can click here and this will start a Jupyter lab in the cloud. So you can run this, and I'll switch to Jupyter lab in a second, but just so you know that you can try JupySQL without installing anything. You can also, there are a few other options here, but the most important is this one. So brief introduction. So you can, the whole idea of JupySQL is to improve the experience of SQL in Jupyter. And here are some just setup instructions. Here I'm just downloading some sample data, but the real deal comes here, right? And maybe many people are familiar with this concept because we are trying not to break IPython SQL's API. So there's backward compatibility, although we are making some changes, and that means breaking some parts of the API. But for the most part, it remains the same. So for those who know IPython SQL, this will be familiar to them. For those who don't know, I'll explain that when you install JupySQL, which is so we have the pip install command here. Once you install JupySQL, you'll have this SQL magic, right? So this SQL magic allows you to run SQL in a Jupyter cell. Now, of course, before running this, you have to connect to a database. And that's what happened here. In this example, I'm using DocDB, so I'm using an in-memory database, and the only argument that I pass is DocDB. If I'm using something like Snowflake or Redshift, I have to configure my credentials so I can connect to the database. Once I'm in, I can run SQL queries here. And for example, here, since I'm using DocDB and DocDB can query CSV files, I can just query this CSV file, but this also depends on your database because not all databases allow you to query CSV files. So at its core, this is what's offering you. And if you have longer queries, you can do the $% version, which allows you to break down your query in multiple lines. So that's kind of the most basic stuff. Now, I'm going to show you some of the other features that allow you to start building more complex projects in a Jupyter notebook. And I'll start with plotting. So plotting is one of the most common applications when analyzing data and when analyzing data in a database. And before we introduced JupySQL, what we saw is that many practitioners were downloading their data locally. So from the database to their local machines, and they're then plotting. And this is highly inefficient and time consuming, because imagine if you have a 10 million row table in Snowflake or Redshift or any other warehouse. It's going to take a lot of time. Depends on your network, but it's going to take a lot of time to dump all that data locally. And then if you're loading this data into pandas, it may blow up, and you may not have enough memory to load everything and then use matplotlib to create the plot. So what we are doing is we added another command that's called sqlplot, and then it takes an argument, which is the type of the plot that you want to create. It takes a column argument and then the table. I'll explain this other argument in a bit, and then it creates the plot. It's actually using matplotlib, but it's a different process. For example, to create a box plot, the only data that we need in our local machine to reproduce this plot are the statistics that we require for the box plot. So the 25th percentile, the 75th percentile, the median, and the outliers. And you can see in the implementation exactly how we are computing these statistics. But we aggregate all this data in your warehouse, and we only transmit like 4 or 5 numbers over the network. Once we got those numbers, then we create a plot, and we call matplotlib to create this. So it's a lot more efficient, because first, you're not transmitting a lot of data over the network, and you're using the power of your warehouse to aggregate the data. And you can also create histograms. So same story. It's the same command. The only difference is that it takes a histogram argument, but it's the same thing. We are not dumping all your data locally. What we are doing is we are just computing the width and the height of each bin. And that's what we transmit over the network. Any comments, any questions so far?
No, looks pretty interesting. Is there an option like with double percent side for sqlplot? Because I guess like with all these arguments, it can get pretty verbose.
Yeah, that's a great question. So that actually has to do with this, with arguments. So let me switch to another section. Maybe let me switch to the Jupyter lab so I can make this more interactive. So the tutorial that I'm looking for is this one. So that's the compose notebook. So let me open it here. And so going back to your point, usually when we are analyzing data, we have to do some pre-processing, and we have to maybe transform the data before we can plot it. And one typical way of doing this is by creating CTEs, right? So the typical with something as, and then you have your SQL, your select statement here, right? And then you keep repeating, and then you add like another as, and then you start having a longer query. The benefit of this is that you break down the logic in multiple places, in multiple select statements. Now, what we did is we added a CTE generating feature that allows you to break down each one of these in a different cell. So this is how it works. This is a data set that has record cells, I believe. So you can see, for example, the name of the record, the ID, the genre, the composer, and a few other things. So let's say, and this actually has multiple tables, so this helps to our example. So let's say I first want to join 2 tables, because I want to get for every track, I want to get some extra information that exists in the artist table. So what I'm going to do is I'm going to store this snippet as tracks with info. So this is not creating a new table. It's just storing this as a snippet in my session. So it's the actual query what's stored. So I store it here. And then maybe I also want to filter by some genre. So I'm going to be filtering by rock or metal. So same thing. I pass the argument save, and then I give it name. Now, I want to join both queries. Let me make this larger. So now I want to join both queries. So then I take the ones that I stored earlier, so these 2, and I'm going to give a new name to this one. Now, if you see here, the one that I stored here, generous fab and tracks with info, I'm also making references to them in the query as if they exist already. So since JupySQL knows that I already stored them, before it runs this, it will build the CTE for me. So it will take the previous cells, and it will generate the CTE statement. And that's why this works.
What does CTE stand for? Is it like
common table expression?
right? Okay.
And then I can just keep making references to the other ones, and it makes things a lot more interactive because I can run small snippets in isolation, and I can go back and say, hey, maybe I want to include some other, maybe I want to include, I don't know, like jazz or classical music, and I can come back here and modify this one, rerun it, and then come back here, and it will detect those changes and it will give me the new results, as opposed to having a gigantic cell with all these ones, and then I'm unable to interactively evaluate each one of them. Now, going back to your original question about visualization, let me show you, well, let me go back to this one. Actually, this was the one that I wanted to show. So the only thing that I'm passing is I am passing the table argument, but this doesn't have to be an actual table. Unfortunately, this is not complete, so let me show it to you here. Yes. So the table, not nulls, because to create this histogram, I removed all the nulls in my table, but I didn't create a new table. I just stored that as a snippet, and you can see that here, right? So I am doing the %% in a cell, cleaning the data, and then I come back to my SQL plot and I say, use that one. And then I use the with argument saying, this is the one that I want to use. Any comments? Is it clear how
Yeah,
this?
I noticed in one of the examples you actually assigned something to, so you executed this percent command, magic command, and then you assigned the result to a variable.
Yes, you can.
How does
Usually,
that work?
yeah. Let me. I think this should work. So I can do something like this, like. So this is part of IPython's magic mechanism, right? Because IPython parses all these magics and converts it into valid Python code. That's why this is working. So if you do this assignment and do this plot, you'll get the matplotlib object. You see? It's a matplotlib object.
Okay. So it's like syntactic sugar for executing some Python function and then
Yeah,
return some result.
exactly.
Okay. That's cool.
Let me show you a few other things that we recently introduced. So there's a lot of convenience methods here. So for example, you can list tables and columns. So if you have a bunch of tables, let's say you have 15, 20, you can do SQL command tables and it will show you a list of the tables that you have. If you want to list the columns, you can do SQL command columns, then you pass the name of the table and it will give you the name of the column, the type, and a few extra columns. These depend on your database. Some of them give you more information than others, but most of them, if not all of them, will give you at least the name and the type. So it's pretty convenient because you don't have to remember things, and if you create new tables, you can keep track of those things. The other important things that we recently added are parametrized queries. So many times you have some SQL query that you want to experiment with and maybe change the value of some thresholds. So for example, here we are defining two dynamic parameters. The first one is the limit. So how many rows we want to show and the columns that we want to select. So we are using Jinja. This has become kind of a standard thing for SQL manipulation. And we can use this syntax, and then before we evaluate the SQL query, we will pass these arguments. And this allows you to do this really simple thing, allows you to do other more interesting things like interactive SQL queries, which is what I'm going to show just now. So you can define a variable that can come from anywhere. So before, in my previous example, it came from a variable, but it can come from an IPy widget, for example. And this allows us to do interactive SQL queries. I actually have to open Jupyter Lab because this won't be visible here. So let me make sure. So it's user guide, then interactive. So let me open that one. User guide, interactive, and then I'll run this. So this allows me to rerun my SQL queries based on some IPy widget. So you see, for example, I am creating an IPy widget. An IPy widget, for those who haven't used this library, allows you to create controls and then move those controls like buttons or sliders, and then modify a variable that then you can use to update a plot, or in this case, a SQL query. So I am filtering. This is a sample data set that has penguins. So each row is a penguin and it has some measurements on their body. So for example, I can change the body mass lower bound. And if I change this, you'll see that these numbers change because I am modifying my SQL query. And if I make it too high, you'll see that all of these, which is the one that I'm changing, this one. Oh no, I believe I'm not showing that column, but you can see the values change depending on this. And this will allow me to create dashboards from this. There's this library called Voila that allows you to turn notebooks into dashboards. So what we can do is to combine JupySQL with Voila and these interactive SQL plots to create dashboards that are highly scalable because everything is running in your database. And if you don't have a database or a warehouse, you can use DocDB, and it will allow you to analyze big data sets in a single machine. The other thing that we added recently is a ggplot interface. So I mentioned earlier that you can create plots with this sqlplot command. This is great for simple plots that only require a table and a column argument. But once you want to tweak your plots, it might become a bit complicated. So when we started working on this API, I started drafting how could we customize the histogram. What if the histogram, I want to change the colors, and I was adding more and more arguments like color and bin, and then I didn't like the API because it felt like not ergonomic enough for users. And then we figured, well, there's a book that tells you how you should be building visualizations, right? So there's this book called Grammar of Graphics. It's an old book. I think it's probably more than 40 years old, but essentially it came up with a formal language to express visualizations. And people who know R, I'm sure they are pretty familiar with ggplot. So Grammar of Graphics are the ideas, and ggplot in R is an implementation of those ideas. And there's also a library in Python that implements this. So we thought, if we are going to add visualization to JupySQL, I think we should follow these ideas because they allow you to build complex visualizations in a composable way. So let me open this one. So it's user guide, ggplot, so I can show you. So the whole idea of the Grammar of Graphics is that you can compose plots and you can create visualizations by adding the different components. So here I have a ggplot component, and now since we are working on JupySQL, the argument that I have to pass to my ggplot object is the table. Since I'm using DocDB, DocDB can also take Parquet or CSV files. That's why I have a Parquet file. And this has, I think, like 3-4 million rows. So it's a pretty big file. And then there's this, we are following closely the API. So this is going to be pretty close to what you can see on R. This object stands for aesthetic. So here you can say, I want to create a ggplot object that's going to use this as the source data. And then in the x-axis, I want to use the trip distance column. Like so far, I haven't told ggplot anything about the kind of plot that I want to create. And that's on purpose. At the end, I say, I want to create a box plot. And then if I run this, it will create a box plot for me. For histogram, it's pretty much the same code, except it takes a geom histogram and it takes a bins argument. And I can run this. And I can change the bins. And then with this composability, you can start adding more and more stuff on top of your existing visualizations, for example, to change the color, right? So it's the histogram with new colors, and you can also create visualizations for multiple columns and then apply colors to each one of them. So you can see that here. I think I have a few other examples. For example, here, I'm also changing some of the settings. I'm stacking histograms. And instead of having one function that takes 100 arguments, you have different functions that have the same arguments, and you just compose them in a different way. So the difference between ggplot in R and this implementation is the same that I explained earlier. We are just computing the statistics that we need in your database, and we only transmit those summary statistics over the network. So this allows you to create histograms for tables that have hundreds of millions of rows. So for now, we only support box plots and histograms, but we are now working on other charts and adding more customization to the existing ones. So I think that's a good high-level overview of what JupySQL offers. There are a bunch of other things that I didn't mention. So I'll just quickly tell you where you can find what you need to get started. So we have a lot of integrations. So if you go to the integration section, you'll see tutorials for many of the most popular databases that exist. So for example, if you are using, let's say, MySQL, you can click here and you'll see a complete example, because if you want to try this with a temporary database running locally, we also have the commands to run a MySQL database using Docker, and then how to connect, and also some tips on how to connect, because we keep seeing users struggling with this because different databases have different rules, and there are different connectors, and some versions are broken in different systems. So we do a lot of testing, and we add notes, for example, on the things that we find. So the idea of these tutorials is to help everyone to get started with JupySQL quickly. And of course, if you have any questions about connecting or things are not working, you can also open an issue or join our Slack community, and we'll answer questions. So we have a bunch of things here. Of course, the API reference that shows you all the different arguments that you can pass to the magics. And I think that's it. I think, well, we also have some how-to tutorials to do specific things. One thing I didn't mention is we have syntax highlighting. Right? I think it didn't show in the Jupyter Live because I didn't install the plugin, because it's currently a separate package, but we're going to merge it soon. So if you want syntax highlighting, you can do pip install JupySQL-plugin, and then you'll get syntax highlighting. And we have a bunch of other short tutorials. We also added recently autocompletion. So same thing, JupySQL-plugin, and you'll get the autocompletion. So that's it.
And you said you have worked on this only for 2 months?
Oh no, well, we started this fork, I think, like 4 or 5 months ago.
Because
And
I'm surprised how much you've done. Definitely not something I would expect anyone to accomplish in 2 months.
Well,
That's a lot of work.
it's the team, the whole team working on this. There's a bunch of people working on this. So yeah, I'm not so hands-on anymore. I still try to contribute, but I also have to do the other part of running a startup. So most of the credits go to the team. They have done an amazing job, and they keep pushing and pushing stuff. So I have to keep up with the new things, because sometimes there are new things and I don't know about them. So then I go and I'm like a new user trying out these things. So yeah, stay tuned for new stuff. We are gonna push a new release probably this week with some new updates. And yeah, we are pretty happy with this with excitement around the tool. And one last thing that I want to say is, if anyone is using SQL with Jupyter and they want to share their experience, feel free to reach out to me. So my email is my first name, Eduardo, @plumber, so PLOOMBER.io. So feel free to email me, or if you find me on Twitter or LinkedIn, message me, because we are running user interviews, and those are really, really, really important, because we want to know what we should be prioritizing. We have so many ideas. We have a small team, and we want to know what we should be prioritizing, what you want to get, what features are missing, or how we can improve the SQL experience.
We will include your contact information in the description. So how many people are actually working on this tool right now?
So we have so the company have 6 people, and they are working partially on JupySQL and on Plumber. So the project that we've been working on for a few years. And we are also doing some other stuff for our clients. We have Plumber Cloud, so we are splitting the time between a few projects. But yeah, so it's 6 people full time. And we also get some external contributors, so that also makes things great for us, because our own users sometimes find stuff that's broken and they just come to us and fix it.
Mm-hmm. If somebody found some broken stuff and want to fix it, how do they go about that?
That's a great question. So if you go to any of our projects, so we are trying to standardize as much as we can. So you go to github.com and any of our repos, and you'll see in the files contributing.md. You click on it and you'll see instructions for contributing. So we are trying to standardize as much as we can. There are instructions for installing dependencies, setting up your environment, then experimenting with the code base, and then opening a PR, getting a review, merging your review. So it's all detailed. Of course, sometimes we have some, we miss some details. So again, you can always send us a message on Slack or open an issue. But most of the important details are there in this document.
Okay. Well, last question. Do you have any advice to anyone who is watching this?
Use JupySQL and talk to me. Other than that, I would say contribute to open source and break things. I think maybe well, that's just an idea that just occurred to me. Like if you have maybe before I started contributing to open source, I felt like going and opening an issue and saying, hey, this is broken was kind of rude. And maybe many times I didn't do it. Now I'm on the other side, and I really thank people when they open issues. Of course, you also have to keep communication polite, right? Because we are putting a lot of effort. So as long as you are polite and you are showing that you did your homework and you tried things and you're documenting what you did, it's great. It's great for open source projects, because otherwise we don't know. We try to do our best with testing. So my advice is, if you're using an open source and it's broken, just go and open an issue. The worst thing that can happen is maybe the team has so many things all at once and we cannot work immediately on it. The best thing that can happen is it's just a small thing that we can fix in a few minutes, and it benefits all the users, all the thousands of users that we have, and that's great.
Yeah, solid advice. Thanks for doing the demo. Thanks for giving us this advice. And I'm sure we will see you soon with some other project.
Yeah, sure. Thanks a lot.
Thank you.